Are you kidding?
That's incredibly bad. So I'm starting this other activity.
Great.
Ron.
Excellent. Good afternoon, everybody. Thank you for joining us today. We will start here in just a few moments. I'm seeing a couple people trickle into today's session. All right, well, I have 2:30 now, so we'll go ahead and start for today. Welcome, everyone, and thank you for joining us for today's session, our fourth section this year with the Conversations with Colleagues. Today's session topic will be introducing a new and free tool for evaluating network level pedestrian and bicycle safety called the Safer Streets Priority Finder. This session is part of the Conversations with Colleagues, which is part of the Bicycle and Pedestrian Data Subcommittee's time to try to have us all join together and talk about various topics at a conversational level. For today, please try to keep your lines muted as we go through and talk. We do have around 40 or 50 people joining us today. If you do have questions, you're more than welcome to use the chat, or if you'd like, you can go ahead and unmute your line if you have any questions for everybody today. Myself and Tony Hull, Win Chung, and Greg Lindsay will be the facilitators for today's session. If you have any questions or any technical issues, please do let us know in the chat so that way we can go ahead and help you and assist you with those. And our speakers today will be Tara Tolford, Daniel Jatries, Jessica Schoner, and Robert Stickney. And at this time, I'll go ahead and pass it over to them. Take it away.
I'm sharing the wrong screen, so give me a minute to fix that. And Dan, you were gonna get us started, I think.
Yep. I'll get started while you're fixing that. Jessica, good afternoon, everybody. My name is Dan Jotras. I'm the Policy and Program Manager with the Mayor's Office of Transportation in the City of New Orleans. Thank you all for joining us today. We've got the official rollout of this great new tool that we've spent the last year creating. Our team, which is comprised of the City of New Orleans, the Regional Transit Authority here in New Orleans, University of New Orleans Transportation Institute, and Tool Design Group, as part of a USDOTD Safety Data Initiative funded project. And I'll have the members of our team that are presenting today introduce themselves in just one second. Jessica, are we all good on? Can you back up? Yeah, there we go. Go forward one. So the purpose of this tool was largely to the Safer Streets Priority Finder, the name of it, was to create an open source resource for practitioners and advocates to be able to easily analyze and understand risk to vulnerable users. And we wanted to do it in a way that required minimal data prep, and then uses a statistical framework that Robert will be talking about in a second to make an estimation around crash risk associated with the road network. And so Robert will talk a little bit more in his section about the research needs and the problem statement and elaborate on that purpose. But before we go too far, I want to give everybody that's discussing today from our team a chance to just introduce themselves briefly. And I guess we'll go in the order that were listed on this next slide. So Jessica, if you want to introduce yourself.
Sorry about that. It's the way Zoom overlays the mute button with your screen always trips me up. Thank you very much for that, Dan. I'm Jessica Schoner. I'm Tool Design's Data Science Practice Lead. And this has been a really exciting project. Thinking way back to TRB 2019 when we met in person to conceive of this project, like before we even had funding, and the way it all came together has been really wonderful. So I'm honored to be here today sharing it with all of you. Robert?
Yeah, afternoon, everybody. I'm Robert Stickney. I'm the Director of Data Science at the New Orleans Regional Transit Authority. Like Jessica, I'm very happy to be sharing this with all of you guys. On the project, I was heading up our, I guess, analytic design team, I think is the name that we had for it, with a lot of help from the wonderful people at Tool to make this happen. And like Jessica said, seeing the evolution of this from scribbling on napkins at a lunch meetup during TRB a year and a half ago to seeing the full-fledged tool that we have now has been a pretty incredible journey. So looking forward to sharing this with you all.
And I am Tara Tolford. I'm a researcher and an instructor at University of New Orleans Transportation Institute. Share the sentiments of this has been such a great team to work with on a product that I think is going to be really genuinely useful and exciting. I know just in my own practice, I found multiple places to use it. That's really my primary role in this project, is to help share it out and find other possible applications and uses and folks who can find it as useful as we are. Thanks so much.
All right, and then there are other members of our team who aren't presenting today, though some are on this webinar watching. So shout outs to Rachel and Beja, Daniel, Jacob, Brendan, Miriam, and Jennifer. I think I got everybody. And Frank, who was with us at the beginning before taking another opportunity, but I think I saw Frank's name on the list here today too. So thanks for joining, Frank, to see the fruition of all this.
Yeah, glad you got Frank there, Dan. Frank was instrumental in setting us up for success on this analysis. He got the gears rolling at the beginning of this project, and without his contribution, I don't know if we would have been able to create what we did for this.
So just real quickly, the overview you see there on the right side of the screen, the tool uses data, your local road network and crash data and a study area that you define, or it can default to some national databases And really the output that we create, which we'll go into more depth later today in this presentation, is some statistics around the crash data, a sliding window analysis to help inform a high injury network. And then the Safer Streets model helps to estimate risk, even in areas that have not had crashes. So I'm going to turn it over to Robert now to go into some more depth about the project and model background. So Robert, take it away.
Yeah, thank you, Dan. I'm going to try to keep this not too crazy technical because I know how people's eyes glaze over when you start getting into the weeds on statistical stuff. So I'll try to use metaphors where possible and keep it engaging. But we'll have a bit to go through in our time frame. So if we can go to the next slide. So our problem statement, as a lot of people on this call are aware, I'm sure, pedestrian and bicycle crashes are not that common in terms of a data set, but they happen far, far too often. They're an issue that can affect all of us deeply, but they're also an issue in terms of mapping out where we find places that might be risky. Now, just because we can't map them out with data does not mean that there's a lack of risk on a lot of road networks and areas around the country. I'm sure we can all think of places in our own hometowns or localities that we feel incredibly uncomfortable walking across as a pedestrian or biking down as a cyclist, even if there has not been a reported fatal crash there. So what we needed to be able to model this was a new modeling framework, a way that we could understand risk even when there isn't a crash history. But it also needs to be done in a way that you can do this without needing a PhD in statistics to get to. So we needed a low barrier to entry, both in terms of the amount of data needed for it, but also for people to be able to use it. From there, we know that there's a few different types of crashes that can occur. Some might be fatal for a person, some might have a severe injury, there might be next to no injury, and it might just be a small fender bender with a bike. So we needed a framework that we could roll all those up together and equate them on an even plane. And then finally, we needed the results to be presented in a way that's actionable for policymakers or anybody who's trying to make a change. So what we saw as a form of that was so that our crash risk actually falls on the road network that we're looking at. You can go to the next slide. Go back one, Jessica. Oh, sorry. No, that is the right one. So what you see here is a visualization done by the tool team on the overview of our model. This is available on the tool itself. We're basically taking in bike and pedestrian crash data, roadway data, and then data from the National Pedestrian Fatality Risk Model, which we'll get into on the next slide. Using the roadway data and the pedestrian fatality risk model, we're coming up with an initial risk distribution and combining that with our observed pedestrian and bicycle crash data, putting it through a Bayesian modeling framework. And our output ends up being on a sliding window segment for the road network, what areas that we have are the riskiest. Now, if all of this seems a bit confusing and all over the place, we're going to get into it in a little bit on these subsequent slides, and hopefully you'll have a better understanding by the end of this and what we mean. But basically the overview is that we're taking a whole bunch of information we have from 3 main sources, rolling it up together and coming out with a model of risk for a road network in a given area, whatever area you choose within the US. Next slide, please. So what you see right here, this map on the right, is a snapshot from a fantastic tool that was developed by the US Department of Transportation, mapping out fatality risk at the census tract level for the entire country. They utilized a lot of nationally available data on things like demographics, income levels, percentage of people taking transportation, walking to work, shopping, intersection density, and rolled that together to create a model using fatal crash data from around the country to see what sort of come up with a recipe for areas that are likely to see a high number of pedestrian fatalities. This is focused on, the snapshot focuses on New Orleans specifically. So it's mostly in an urban area, but they also tested on rural areas as well. They validated this against the very popular high injury network framework done in Los Angeles, and found that the high injury network could predict some areas a bit better than their model. Their model could predict some other areas better, and they also had a lot of overlap between the two of them. But there's additional validation needed, and we also wanted a bit more refinement on this so that we could actually map this on a street network. If I turn this over to any policy decision maker and said, yes, these areas in red have a high risk of pedestrian fatalities, let's fix this, I don't think it would be, there wouldn't be too much action they would be able to draw from that. So what we saw as our sort of peanut butter and chocolate was finding a way to combine high injury networks and this pedestrian fatality risk tool. Next slide, please. So the modeling framework, we needed our model to be able to use data that anybody can get around the country. We needed it to be able to estimate risks on a segment, not just at intersections and not just an entire polygon. And we needed to be able to estimate risk in areas that don't have an existing crash history. They might be smaller population levels, more sparsely populated, or maybe there's an adjustment made and it's a relatively new intersection. But just because we don't observe risk, we don't observe crashes, does not mean that there's not risk inherent in it. Existing models that we can see are like the high injury network sliding window analysis, which have crashes on a segment, and they take into account history and proximity of other crashes. Safety performance functions, which are also crashes on a segment, but they have a large amount of data required to be able to implement them. And you need to do them on a project by project basis. And then there's the pedestrian fatality risk tool, which has crashes in a polygon level, but it utilizes nationally available data. Go to the next slide. So our model, what we're calling the Safer Streets model, produces crash risk on a segment by taking in initial risk distribution. We revise it from history and proximity, meaning we take existing information that we know about causes, potential causes of crash risk, and we combine that with observed data and essentially redistribute where necessary within our model and give an output from that. This is done through a process, goes by a few names, but we'll call it Bayesian updating to bring these two together. You can go to the next slide. So the big question, why Bayesian? Or for some people on this call, what is Bayesian? Whenever we're allowed to have parties again without worrying about catching a respiratory disease and dying, impress any statisticians that you might meet at a party by asking them if they're a Bayesian or frequentist. And if you're wondering what the difference between the two of those are, I've come across a lot of people who have taken stats as a course in college or high school and come out saying it's really hard and confusing. Generally, they're taught from the frequentist school. The Bayesian school is a bit more intuitive to people, for people to understand, partly because I think it's a bit more realistic and ties in more into how people think. So if I go to a restaurant that was completely new in the city, I sit down, I have a mediocre meal, I might think, well, they're all right, I'll give them another shot. Maybe they just had a bad day. If that same instance, I go to that restaurant and this is again my first time going there, I get food poisoning, I'm probably not going to go back. Maybe I give them another try. Or a third scenario, I go to the restaurant, halfway through my meal, the owner of the restaurant comes out in a jester cap with a machete, starts chasing me around with bloodlust in his eyes. I'm probably not going to think, I wonder if this is an exception. I probably need more data on this. What I'm actually going to be thinking is, oh my God, I can't believe this is happening. The fortune teller was right. This is the day that I die. So that Bayesian mindset really comes into play with riskier or more important data. I'm sure you've all experienced at some point somebody saying in your life, well, we can't really make a decision, we need more data. But when the jester cap clad restaurateur is chasing you around with that knife, you're probably not going to wait for more data before you decide not to go back there. What this means for crashes is that if we see a fatal crash occurring on a segment, maybe it's a safe intersection, this was a fluke, but there's probably something going wrong. You can go to the next slide. I just saw PBM. The polygon-based model has been our project shorthand for the US-DOT pedestrian fatality risk model, mainly because it's a mouthful for us to say that every time we refer in an email or a conversation. So we built this model. We utilized as our prior, and going back to the restaurant analogy, I know that sometimes restaurants have good and bad days. I know that sometimes that generally restaurants should not give you food poisoning. And in this instance, I got food poisoning. So my prior knowledge is my knowledge of restaurants, even though I only have one observation of that particular restaurant that I'm talking about. Our prior in this model was the PBM or US-DOT pedestrian fatality risk model, as well as our understanding of the rate of fatal crashes occurring on different roadway types throughout the country, be they arterials, local streets, highways, et cetera. And our observed data that we're using to update this is our crashes that we observe on a road network. Now, with this, there's two types of possible errors that we're looking at in terms of where our model could go wrong. We could identify safe streets as being unsafe, which means that it might lead to somebody investing in an area that doesn't need it and wasting funds. But what's an even bigger concern is we identify an unsafe street as being safe. And the risk that we run there is if we overlook an area that is inherently risky, but label it as not being risky, then there's more likely for people to be injured or lose their lives because of inaction. Now, understanding this, we needed some way to tell how well our model was doing, whether it was right or it was wrong. Maybe some of y'all have heard the famous quote, all models are wrong, some are useful. I'll add another one that a former boss and mentor of mine said, it's not whether or not our model is right, it's whether or not it's more right than the previous model we were using before. Maybe y'all have heard the joke about walking in the woods and a couple walking there and a bear comes and starts chasing him. A guy steps down, starts tying his shoes, and the guy next to him says, you can't outrun a bear. And he says, I don't need to outrun the bear. I just have to outrun you. So we're just trying to outrun our friend as we hike together in the woods. So we needed to compare this to a current model that's being used. And this is, I have to give a big shout out to Teja Putta for this, because this was his validation effort and a project that he went with on it, where we compared how we did against a sliding window segment or high injury network model. So what we did was, and this was primarily Thasia, took crash data from 2010 to 2014 for Orleans Parish in New Orleans, for Lincoln Parish in Louisiana, which is a rural example, and for Lowell, Massachusetts, which is a small town in another part of the country. And using the Safer Streets Priority Model and high injury network model, he compared the, he generated an output on what the most dangerous segments were for 5 years of data from 2010 to 2014, and then saw how it worked out with crash data from 2015 to 2019. And what we found was that in every crash category and every single instance that we looked at in every validation jurisdiction, our model outperformed the high injury network model. And even more importantly, on fatal crashes and severe crashes, our model, I won't be shy on it, our model blew the high injury network model on it out of the water. So what we found was basically we did better, which was great news for us. Go to the next slide. This next slide on cost calibration, I'm going to flip it over to Jessica for it. But I know I didn't go too much into the math on a lot of this stuff, but I'll be around for questions afterwards if anybody has any specific questions.
Okay, thanks, Robert. So I can address the cost calibration, and then we're going to go through a tool walkthrough. So as Robert said, we found our model performed really well when we were pitting it head to head against a simple sliding window analysis that only looked at historical crash data. But when we look at the actual magnitude of the outputs, how many crashes is it predicting on any given segment, we were actually running a bit high. In urban areas, it was predicting maybe 2 to 3 times as many crashes as we observed. In rural areas or areas where there just aren't many crashes, we were predicting quite a bit high. We found that the relative distribution on the network looked pretty sound, though. It passed the smell test when run by locals. It performed pretty well. So the segment that scored the highest may have a number that's astronomically higher than the actual observed number of crashes, but it's still, maybe the top 5 or top 10% highest score by both observed crashes and our model output. So we're pretty confident in the internal relative distribution of results, but as far as the magnitude of results, we used some calibration to just bring that total down. So when you see results in the tool and they're expressed as dollars, know that they have been scaled so that whatever observed crashes you have in your study area over 5 years, the model results have been scaled so that it matches that. This also means if you have a study area with very few crashes, you might actually not see too many results in the map viewer yourself. We can walk through this in the demo, and there's documentation about this in our frequently asked questions section, but you can always pull the data out and look at it later. So just going into it, understanding where the models and data are coming from, we're really excited to show you what the user interface looks like, because that's the fun part. So let's skip ahead. First, just a quick list of what this tool does and doesn't do. It's an online tool that can use your crash and other data sets to look for risk on a network. So we're using a sliding window analysis and the safer streets model. That's the Bayesian model that Robert told us about. And so you can look at the results of both of those. The simple sliding windows analysis is the foundation of what most places use when they build a high injury network. So if you just want to stick to the basics, that's built in the tool, it's there. And then the Bayesian model is there as well. And we think it performs really well for building a high injury network or just using it to prioritize on your network. The models can handle both pedestrian and bicyclist crashes. You can also run a simple sliding windows analysis for motor vehicle crashes, but the focus really is vulnerable road users. And you can visualize some of the results and upload some supplemental data sets. And the outputs of the Safer Streets model are expressed in costs. So you could use it in a benefit cost analysis. What this tool isn't, it's not a full-on benefit cost analysis tool. You can't go in and draw, what if I improve this street? What would the change be? Great idea. We'd love to do it sometime. We're not there yet. It's not a scenario analysis. We're making no claims that this is predicting the future. Rather, it's taking a combination of nationally available data and our best estimates based on what we know about functional class and your historic crash data and saying, if trends continue exactly as they are, this is what you might see. This is how you might prioritize things, but don't send your lawyers after us. We're not predicting anything. There aren't countermeasures built into this, so you still need to work with your public works, your engineering department, and help figure out what you're going to do once you find high risk streets. And we're still working on building a model for motor vehicles in that Safer Streets model, the Bayesian framework. And this isn't full, this isn't ARC Pro. There, you can't do a ton of heavy GIS analysis in the browser. You can do quite a bit, but it's not meant to replace what you can do in a separate tool. And the data and the data entry point is actually pretty low. We've set this up so that you actually could go to the tool right now and run it with no data at all, just using the defaults, although that's not usually recommended. So as an end user, you would need you need a study area, and so you can have a shapefile of that, or you can just choose a county that's built in. You don't need to upload anything. You need crashes. So if you can get crashes from a state DOT or from a public agency, that's fantastic. Many states make these available through an open data portal. In some states, it's a little harder to get, and our frequently asked questions has a list of where you can find crash data to use. If you don't have any, you can use national data that's built into the tool from the Fatal Accident Reporting System. using fatal crashes only can lead to some wonky results. They tend to be a bit sparse. We really need the severe and other injury crashes to help understand the full extent of risk. So it's not recommended, but in a pinch, you know, it's better than nothing. And you either need a shapefile of your roads data set, or you can use built-in OpenStreetMap data that has functional class in it. We think the OpenStreetMap data is pretty good, but like if you wanted to take the results out of the tool and have a joining ID that would join it back to the identifiers in your linear referencing system, for example, you can upload your own, and that way it comes out joinable to your original data. And we're going to take a look at the tool. But before we do, I have to give you the obligatory disclaimer. We're going to walk through an example showing data from the city of New Orleans, and I can't flash this disclaimer on a live demo. So here it is now, that we're using the data for identifying, evaluating, and planning safety improvements. And it's not, I don't know, it's the USC 409 thing. The other disclaimer is that this tool is still in beta. We accomplished a lot over the past 11 months, and we're really proud of this work, but also just, you know, to manage expectations, it has a little bit of a tough time with multiple users. So if everyone jumps on and tries to like walk through it while I'm walking through it, the demo is going to slow way down. And so we want you all to try it out, but maybe don't everyone do it right at the end of this webinar, or go ahead and do it, but just be prepared for, you know, it would look like stress testing a tool. You might get some processes taking a while to run. So just send us all your thoughts and feedback, and just keep in mind, this is still in, we're calling it beta release, proof of concept. Yeah. And with this, I'm going to get out of the PowerPoint view and pull up my browser somewhere. There we go. So you can, the Safer Streets Priority Finder webpage starts with just some basic info, so you can read a little bit about the tool without having to log in or do anything else. But when you're ready to access the tool, you can create a login. You don't have to, you know, it's just free to access. You can set up an account. I already have an account, but we're going to walk through a new scenario right now. So I'm going to enter my credentials and create a new study. The tool only lets you, that's TRB. The tool only lets you run one county at a time. So if you're, for example, working with an MPO or a state DOT and you want to look at multiple counties, you can create multiple studies on your login and do one for each county. That way you can, you can run them without running such a big study that it bogs your our system down. So the welcome page has some info about contributors, all the disclaimers, good stuff. There's a pretty extensive methodology section. Much of this information is also included in a manuscript and final report, which I believe should be linked somewhere. So that's available if you want to go a bit deeper into how this Bayesian model works and what the inputs and outputs are, what some of these concepts are, how we're calculating costs. There's a lot of good stuff in here. There are step-by-step instructions. If you are a visual or you like to learn by reading, it's all here, so you can walk through. The data requirements, as I said, are pretty simple, but there are some examples of how to have your data set up already in case you need to do some light restructuring in QGIS or ArcMap or whatever GIS software you use. That's all in here, but I'm going to start by walking us through the first step towards a study, and then we'll skip to a study that's already done. So the tool's set up to make it really easy. You can just dive on in. We're going to choose Orleans Parish, Louisiana. And we're going to upload some road data. Actually, we're running low on time, so I'm not going to walk through this step completely, but I am going to tell you when you do this, the tool walks you through a few steps to clean and standardize your data. So you have to tell the tool which field is the name of the road, which field is a unique identifier. And the same with crashes as well. You have to tell us what field is mode and severity. And then you can run the two different analyses, sliding window and the Safer Streets model. So I'm going to hop over to a study that has already been done. This is, like I said, Orleans Parish, City of New Orleans. So we've got the sliding window analysis, and this one looks at historic crashes only in sliding window segments. My map is lagging just a little bit, but this is like the foundation of a traditional high injury network. If we were building a high injury network before the Safer Streets model existed, this is the same process that we would run, and we would look at a cutoff or a threshold in this score to help define what's on or off the high injury network, or you can keep it in this heat map style. And just see where your top segments are. So this is looking at a weighted crash density score. So segments that score high have had the highest combination of fatal and serious injury and minor injury crashes by mode. And you can look at bicycle, you can look at pedestrian, and then there's a third option. You can look at other, which in this study is set up to be motor vehicle crashes. You can see the freeways tend to pop out a bit more than the other two scenarios. You could use this for anything. If you wanted to look at motorcyclist crashes specifically, they're pretty vulnerable road users. You could do that. You could use it for transit vehicles. That this is really your catch-all. You can set that other to be whatever you want it to be, whatever you want to study. The other analysis is the Safer Streets model, and this, just going to warn you when you try this out, it can take several hours to, depending on how many people are requesting a model, several days to run. The Bayesian framework is really powerful for what we're trying to accomplish. It also is just a processor hog. So, plan on signing back in later. You can it sends you an email when it's done, but you can see the results are similar, but a little bit different from what the results on the other sliding window analysis were, because this is incorporating that other information we have from the pedestrian fatalities model and from functional class to help estimate risk, whether there have been crashes there or not. So those are two analyses. There's a data dashboard where we have some basic summary statistics about your crash data. You can look at distribution by mode and severity. This can be really powerful if you just need some information at your fingertips, like you need to show in a report that, pedestrian crashes may be a pretty small share of crashes, pedestrian trips may be a pretty small share of trips, but they comprise a much larger share of fatal and serious injury crashes. Well, that data is right here. We can see, in this data set, pedestrians comprise 30% of fatal traffic deaths in the study area. So this is all just coming directly from your data. You can see by functional class, by year. There's a top 10 segments based on the sliding windows score, and you can also see some model fit statistics. I told you that the model was calibrated. So we brought just the observed cost of 5 years of crashes equal to the modeled cost, but there's still variation by severity level. So you can see we're maybe over predicting fatal crashes a little bit and then under predicting the lower severity crashes in a way where the costs are then about constant, but just so you can kind of see and get a feel for how confident you are in the model, what that distribution looks like. I think this is still looking pretty good. The fatal ones are the ones we really want to focus in the most. So from this page also, you can download any data set that you uploaded, as well as the results of your analysis on a network. So you can download a shapefile that has your road network and the sliding window score on it, or a shapefile that has the Safer Streets model scores on each segment. You can also download a report that has all of this information and all of your maps, which I'm going to pull up right now. So this is also pretty handy. It comes to you as a PDF. The report function, like the model function, takes a little bit of time to generate, especially if a lot of people are requesting one all at once. But once you get it, it's pretty useful. It walks through what data you put in. It includes all the summary statistics that you saw in the dashboard, as well as the maps of your sliding window and Safer Streets model outputs and model fit statistics. So pretty handy. And then finally, there's the map visualizer, where you can choose whichever combination of data sets you want to look at and map them together. And you can also upload a separate layer. I'm not going to do that right now, but you could look at over an overlay with, say, transit stops in the region to see what are safety conditions near my transit stops and how might that affect decisions I want to make on prioritizing road improvements near transit or stop spacing. I'm sure Robert could talk more about that and Tara will cover some of that in our use cases, but you can turn layers on and off. In this case, I'm looking at pedestrian crashes overlaid with the pedestrian risk model, safer streets model, and the census tract ped fatalities model. So you can see them all kind of overlaid together. Let me turn off the crashes because I want to show one useful thing. So that pedestrian fatalities map that we're building in as a prior for our safer streets model shows this census tract, which is huge, as the highest risk in the region. But what we really see is that the risk connected to that is concentrated along this road that is the boundary of the census tract. And this is true in a lot of cases where it's a major arterial that's actually the boundary of a census tract that that carries most of the risk. And so we this model helps allocate that risk to the roadway. And then you can poke around the website. There's use cases, there's FAQ, and I think I've been talking too long. I'm going to pass it to Tara now and go back to our slide deck.
Awesome. Thank you so much. Yeah, so we've already talked about some of the ways that this can be used. We wanted to give a few sort of specific examples of how we're using it so far, and some of the ideas we have for how it could potentially be applied in the future. Of course, one of the reasons we wanted to come to this group specifically is that we think that y'all will have the wherewithal and B, the interest in trying it out and giving us more ideas. And I think at the end, there's an email address to provide the feedback about anything that works, doesn't work, moving forward. So obviously the City of New Orleans was the primary partner on this project, and our primary goals were to develop something that would meet our local needs. New Orleans, for those of y'all who are from here, is a fantastic walking and biking city, but we have some pretty big safety problems. Previous analyses that the city had done to address those had often focused on just intersection crash frequency or sort of standard hotspot analysis. And that's a great start, but it wasn't really getting us where we needed to go, which is figuring out, okay, so how do we prioritize the most impactful investments across the whole street network with limited resources? And then more importantly, perhaps, we had the identified need to really find a way to come up with a sort of bottom line assessment of the potential value of interventions in terms of the cost of not doing anything. So if we do not change things, what can we expect in terms of the societal, the human cost of fatal and serious crashes moving forward? Because that's a really powerful piece for making the case for whatever it is that you want to do. And finally, we just needed a way to develop stronger grant proposals that are more data-driven and find ways to rank our projects internally, either for the whole city or usefully for very specific sub-areas. So if you didn't want to use a county, you could just do a single neighborhood and run the whole thing. And you would have a way to compare and contrast within those. Next slide, please. Okay, so pretty much the whole presentation to this point has been designed around how did we address those goals. So I'll just kind of skip to the results here. And what this gives us, and you kind of saw this in the walkthrough since this one's the same geographic area, is we get this list of where are the places where we have the most opportunity to make improvements for pedestrian and bicyclist safety. We've talked about using it as potentially baseline data for future project impact evaluation, especially if we're able to periodically update the model and the data moving forward into the future. This could be a sort of useful standardized way to see how we're doing over time. And as I mentioned, it's really important for having that cost of the no action alternative, whether it's at the corridor level or for an area or citywide. Next slide, please. So our other major partner, RTA, as a transit agency, they were really interested and had specific goals about how to use this for understanding safety issues impacting transit riders themselves. Everyone who takes transit pretty much is a pedestrian. So we want to address systemic pedestrian safety issues along and adjacent to transit routes, as well as being able to look at crashes involving transit vehicles themselves. And Jessica mentioned that other category gives us the first in to start to do that. We can plug in those transit crashes and we can understand where they are occurring in relation to the traffic and functional class and built environment factors that might be contributing to those issues. So what it gives us here, and this illustration is just showing if you do layer in your transit stops, you can start to visually understand where high crash areas, corridors are in relation to your transit routes. out they align pretty frequently as major arterials, but it also, we can then layer on the transit rider volumes so that we can find what are those places where there are a lot of safety issues for pedestrians, and B, a lot of transit riders, so that we can prioritize those moving forward. And then also the opportunity to look at the transit vehicle crashes themselves, as well as just pedestrian safety issues, can be a useful input in training to understand what the systemic risks are, whether there are specific factors we can dive into that are contributing, so that operators of vehicles can really be aware of what those potential built environment issues are to look out for. Next slide, please. And then finally, we also wanted to give you at least one example of not New Orleans for how it can work for a totally different type of context. And that, I think, is one of the really powerful things about this, is that you can apply it in a place that maybe has less capacity for planning and GIS work and needs something that's a little bit simple and easy to use, but still gives you some really robust results. So we have a partnership with Ruston in northern Louisiana, which is a small, mostly rural parish, Lincoln Parish. And they have been, over the last few years, really working to build out their pedestrian and bicycle network with a whole bunch of funding sources and a whole bunch of partners. It's been really cool to see, and it's all really focused on health equity. So we are integrating this tool into our health equity analysis to understand to what degree the network is lining up with where the safety needs are, as well as where to prioritize future interventions based on where we're seeing crash results. And this is a place where they don't have a ton of pedestrian and bicycle crashes, especially as they've just started to really build out this network, and there's an increasing volume of people walking and bicycling. So having those other factors from the model helps us to see, even in places where maybe there's zero crash history at all, where we might expect to see crashes because other places that are like that have those sorts of issues. So this is a really useful thing to be able to add to their arsenal to namely go for future grant funding so that they continue to build out that network in their sort of scrappy, awesome way that they've been doing. Next slide, please. And then finally, we have, we've started to assemble some of the lists of who are all the folks that we think could potentially be using it, whether that is state DOTs to use it as possibly an input for competitive grant applications. Certainly there can be regional uses if you do all of the different counties within a region. We see this particularly in places where there is access to public crash data. Louisiana is not so much one of those, but plenty of other states and cities do have open data sets that anybody could use it. You could have an advocacy organization or a neighborhood group. Certainly university folks I know will be interested in being able to sort of plug and play with this stuff for any number of screening purposes, complete streets policy implementation, advocacy campaigns, and the like. With that, I will kick it back to Dan to close this out.
Thanks, Tara. I'll keep it real brief here so we can get to our Q&A. So on the next slide, just a reminder of a few limitations of the tool. The results should be used with caution when there's low crash observations. Right now, it's the model itself is for bicycle and pedestrian risks. You'll see over on the right some future ideas. Expanding that model to other users is one of those things. And the final limitation we want to note is that the tool will experience some delays and latency when multiple users are processing data at the same time. I won't go through the full list of future research ideas, but like Jessica and others have mentioned, we accomplished a lot in a year's time of this scope, and there's a lot more great ideas that we have that if we can secure the resources, we'll move forward with. And of course, users such as yourselves may identify other future directions and features that could be added into it. The chat on the next slide, the chat box, we shared the URL already, saferstreetspriorityfinder.com, but you can go and check it out on your own. There's also some tutorials, including the one linked here, that are YouTube videos that lead you through. And finally, just to a final note on beta testing, like Jessica mentioned, the tool is still in proof of concept. go ahead and use it. If you encounter any glitches, please let us know about it. Or if you have ideas about additional features, the Safer Streets Priority Finder at tooldesign.com. You can send everything to that address. And I guess we will turn it over now to Q&A from the audience.
Yes, thank you, Dan. Thank you all. That was a great presentation. It honestly looks like a really exciting tool. There have been a few questions that have been answered throughout the presentation, but if you have any questions, feel free to either use the chat, or if you'd like to unmute yourself, you're more than welcome to go ahead and do that.
Nathan, can I ask a question?
Of course.
Yeah, originally I thought, Jessica just speak very fast, but then when I see her input in the chat box, oh my gosh, her typing is very quick as well. Thank you, Jessica, for all your quick response about those the relationship of those 4 different models. And regarding the cost, I'm just wondering, how do you calculate the cost? Because the crash cost is very complicated, right? Including the production loss or earnings loss, whatever. So how did you calculate the cost, and how do you consider the impact of inflation?
Rachel, do you want to address that one, or do you want me to do my best on it?
Why don't you take a stab and I can chime in?
So we built out national level costs, just kind of aggregate cost to society based on crash severity. So in our methodology, you can see what these are, and they incorporate a discount rate of 3%. So you could sum the cost over 5 years, or aggregate it kind of on that scale. You can also customize them in the tool. So if your state DOT publishes costs, you can update them as you're walking through the data import process. So, you could type in your own costs. We're anticipating updating this every year or two. So that would handle inflation on these, built-in costs, but you can also address it that way. We're building from the methodology described in FHWA's crash cost for highway safety analysis. So you can see that that link from the methodology section of the tool. But, I know a lot of states publish their own crash costs. Louisiana does. I know Caltrans certainly does. It really, a lot of state DOTs have that. So you can type in your own, as you're uploading your crash data, there's a spot for you to do that.
Thank you. I have a natural follow-up regarding the cost. So you mentioned that the model output cost sum is greater than the sum of the observed crash cost. I'm just wondering what's the reason?
Our model is just frankly over predicting a bit, and we expected that to happen to some extent because we are estimating risk on on the whole network. We're spreading risk around. We're using both crashes that we are assuming may happen because of the functional class and the SPED fatalities census tract model, as well as the observed crash history. So it was always set up to overestimate a little bit. And so, but since we found the internal distribution satisfactory, as well as the just the relative performance relative to a sliding windows analysis to be quite high, we at this point just did a simple linear scaling to bring the 5-year observed in line with 5-year estimated. And so that's not perfect. That's certainly on our list of things we'd like to build out a bit more robustly. And if you have thoughts or ideas, absolutely get in touch with us, because this is it's ready for people to start playing with, but it's certainly not the end. We want to keep building.
I have no ideas at this moment, but I think it's a good explanation. Thank you.
And reminder too that we figured it's better to be overly cautious in some of our crash estimates than to be underestimate them.
Thank you.
Yeah, and this is Tony. I have a question also for the team. Obviously, there was funding for this project to develop this tool, and so it seems like it's been a very positive outcome. What is the sense, or is there a plan for how, obviously with a tool like this, the ongoing maintenance, and I think in particular, the capacity, if it becomes popular and people are using it, to be able to expand it, which I'm sure is just a matter of cost or hosting for this. And being that the FHWA was involved with the origin of this, is there a strategic plan for them in terms of how to roll out and expand this once it's past the beta testing phase?
You've described my to-do list. We have this funded to host for 1 year. So the costs of hosting are covered at the current level. Some of the latency issues with multiple users has to do with the underlying tool architecture, not not just the size of the server it's running on. So it's not as simple as scaling up. It would actually need some revisions in the architecture to make it handle multiple users better. So if anyone on this call is an R-Shiny developer and has experienced scaling applications, get in touch. And we are working on other pathways to build this out and keep it alive and running for a long time. So, if anyone has ideas on pooled fund or other agencies that may be interested in investing and expanding it further, we're all ears. And Dan, you're the PM on this whole project. Is there anything else any other thoughts you have?
I think you covered it.
Oh, and I see Greg's note. Again, I'll invite everybody to know that we've got just less than 10 minutes left here. But I do encourage if folks have some questions, use the chat box there. I guess I will remind everybody, the email that you presented for the sort of project at the Tool Design Group, is that where people should contact if they have input or things as they beta test the project?
That email address goes to Daniel, who's our lead developer on this, Rachel, and myself.
Okay.
If you have like a New Orleans specific question or an RTA specific question or university specific question, they are not included on that email. We can certainly help you get in touch, or you can reach out to them directly.
And then we see there's a question that came in just now. Are any state DOTs beta testing it? I guess it asks specifically about Louisiana, but also other states.
So not yet. That's definitely on our plan for the fall. We've provided an introductory presentation to some folks at DOTD, and we want to bring it back to them now that it's actually completed, to talk about some of the potential applications and how it might be integrated, as well as just to get their safety folks in the tool and working with it and helping us identify anything that needs to be addressed in the future. So definitely that's on our radar, and we're happy to share any findings with other state DOTs or other jurisdictions as they develop that might be useful.
Sounds great. We have Peter Bennett has contributed, I think, a comment here. I'll read the group here. I thought of two ways you may or might be adding to the model. One, supplement functional class with measurable street characteristics, example, width and speed. Add near miss data, although self-reported near misses can be biased and thus makes the model a little less predictive. Interested in thoughts on those ideas.
Yeah, we started with the data that we use right now, which is just functional class and this national scale model, because we wanted to build to that lowest common denominator of data that people have available. If you can get a crash data set that has mode and severity, you have everything you need to run this well. And so being able to build it out further with other roadway attributes, it would be really valuable. Especially if you think about then, let's say, screening the network on higher speed or wider roads, there's a lot of potential to build this out further. We wanted to start with that entry data point for people who don't have $50,000 to consolidate all of their roadway data onto a single set of line strings. So I really like your ideas, and thank you for sharing. And we're gonna make note of those.
And it sounds like Greg's, you're sort of answering what Greg Lindsay there is asking behind us, is what the priority would be for build outs, and what the next variables would be that you'd like to include ideally.
I think top of our list right now are the architecture, actually, so not the model, but the architecture to handle multiple users. Our lead developer, Daniel, who is just completely brilliant, has a plan that he's already started building out, but it needs a bit more work to make it handle the multiple users pretty well. So we're working on that. And then the other is this pedestrian fatalities model is actually from a 2018 publication, and it uses input data that's a bit older than that. And so we have started re-estimating that model to get a newer version that uses more recent national base data. So those are kind of the two low-hanging fruit, like these are the next things we really want to do. But then beyond that, you know, the Bayesian model for motor vehicles would also probably be pretty high on the list before we start thinking about other variables to add to the Bayesian model for the other modes. But as always, send us an email with your thoughts. We want to hear all of it.
And Greg, I'll add to that too, that for us, the USDOT model, PPM, whatever we want to call it, that pedestrian fatality risk map, that sort of functioned as a proxy for us for exposure. But if we would happily, if we can find a large scale data set that lists exposure better, happily include that. What we found though is, at least for now, this works well enough for our purposes.
Well, I think we're getting pretty close to the top of the hour here, so invite Nathan or anybody else make sure we wrap this up. I will remind everybody, first of all, thanks. We've had great attendance. I think I counted at about 76 participants here at one point. So obviously this topic is resonating well. The team will be sending follow-ups to folks who do attend. So we'll send any other references and links and some of the data that you've seen in the chat box. So don't worry if you missed that. And a reminder, this is the third of the conversation with colleagues we've had this year. We will look to probably still have another fall one. So we haven't tied down a specific topic yet. So if there's something that somebody has an interest in or would like to actually be a presenter for this, contact myself, Greg Lindsay, Nathan Hicks, or Wen Chen. We're happy to sort of talk to you about hosting these. And then
Tony, oh, sorry.
Oh, go ahead, Robert.
I actually have a question for the wider audience here, because I'm seeing a lot of representatives from different types of organizations. And I was wondering, and Brian, I'll get to your question as well. I was wondering if the participants here, if you could possibly list what type of organization that you're with and whether or not you think you would use the tool or find a use for it as well in the chat. That would be very useful for us.
Yeah, and if folks could just go throw that into the chat box, because we will capture all that. So and we'll leave it on for a few minutes there. I think both the organization you are and the type of organization, and then yes, a comment about the relevance or how you might use this. Thanks for that. I think that's a great bit of feedback to get, Robert, and we'll share that with the team.
For Brian's question on if any quality assurance was performed on the crash data set, the crash data set that is the default for it, the FARS data set, is a nationally available data set. Any other crash data set that is used, that is for the user to verify themselves. This is very much you plug in your own data. So we would hope that you'd be able to clean up your data sets and figure out any issues that are in it before you start using the tool.
Well, excellent. Well, it is right there at the half hour here. I do want to thank everybody that presented. I think this has been fascinating. I'm excited to actually go play with the tool. I think that's going to be fun for a lot of folks. And I do want to entertain the idea, since this is the beta opportunity, as this moves forward and we get to another stage of this may be another a future conversation with colleagues topic. So we would look forward to maybe revisiting this as it starts to become a more mature and used tool for folks. And Greg, if we could just leave, I guess we can leave this open so folks can enter their things in the chat box for a few extra minutes while we sign off. That would be great. And then Nathan, Wen, Greg, I don't know if you had any other final thoughts or things you wanted to share with our audience before we end the broadcast.
Just wanted to thank them all for their time. Thank you very much. This was a great presentation today. We'll be sure to send a follow-up email to everybody. And if we have any missing questions, we'll be sure to add those also into that summary. Thank you very much.
Yeah, and I will also just shamelessly plug, since it's a week away from the deadline, for those of you who have things to share, such as this great tool. It is a call for proposals for APBP, the Association of Pedestrian Bicycle Professionals, for the 2022 webinar series. So that's open. I will put that link here in the chat box for folks in case there's an interest. I certainly encourage, and actually this is maybe something as this comes forward, we may also work with APBP to see about sharing this with that audience as well. So with that, are there any other final comments from the team? Anybody want to share before we sign out?
No, thank you so much for inviting us. I knew this would be the right group, and it's been a pleasure.
Well, thanks. No, this is I think it's been a joy for our attendees, and we appreciate everybody taking their time today. And watch your email. Look forward. We'll have another session coming up in the fall, and of course, for some of us, COVID willing, we may see each other at TRB here in January. We'll wait and see on that. Thanks, everybody.
Thanks, y'all.
I'll be right back to shut down, Tony. I'll be right back.
Okay, yeah, I'll sit here and we'll just make sure we capture anything else in the chat before we do.
And do you need anything else from our team, or are we probably good? Or
Yeah,
I can stick around. I got nothing scheduled.
yeah, no, I don't have anything until the meeting a little bit later. So no, that was great. I was so glad to have the whole team. That's a really exciting project. So
Yeah, thank you for the opportunity. This has been our baby basically for the past 11 months. It's been so much fun.
It made me realize too for this, and we do the conversation with colleagues 3 or 4 times a year, and we try to do this smaller, like it's a lot more usually chat. This was we probably should have planned around a 90-minute to really allow us to get into some things, because I think there's so much to cover in terms of going through the tool and its application. It didn't really give, I think, folks that opportunity to really get engaged and start chit-chatting, but at the same time, I think everybody really enjoyed it.
Yeah, I'll take some responsibility for that. The time spent on explaining the methodology, I went over what I had intended to. So my apologies on that.
No, that's, I mean, I think it's important. And this is actually, I would say, the audience that kind of appreciates those details. So, you know, I think that allowed for some good content. And hopefully, and I'm hoping that the folks that are attending, again, you know, we had over 70, and we do have some pretty good agency representation. So hopefully we get some good feedback from folks as they get a chance to look at that. And of course, we'll send out, I mean, our team will send a follow-up out to all the attendees, and then Greg and I, because Greg's capturing everything, so we'll have the chat box, so you guys can get that in a follow-up email. And we'll be sure to put that follow-up email out. We'll include the links and everything. So we'll keep you on that email thread to make sure that we have everything relevant that you guys want to share.
You know, sorry, Jessica.
Oh, I was going to say, we've done some internal stress testing, having multiple people try to use it at once, but this is like the first real world test. So I am super excited to see what people do when they get the link and how it goes.
It'll be fun. Yeah, I'm saving the link and I hope to play with it. I figure I'll play for the weekend or something when I'm goofing off, but it's.
Yeah, I know, at least from the transportation side, and this is something that we realized a lot more heavily when I started beta testing this in our organization, particularly with our safety department, is our chief safety officer was saying we should really be pushing to try to roll this into, they call it SMS in the transit sphere, to see if we could find a way to incorporate it in that, because that was where I got the best feedback from in our organization, was our safety team. So really help drive that. We'll have to try to expand the audience to get more transit people in, I guess, next time.
Well, personally, that's where I'll be more interested. I've worked on similar technologies and tools in the past, trying to like solve similar issues. And the real story at the end is when it actually starts being used as an application and affecting decisions, operations, project prioritization, that sort of thing. So That'll be, and that's actually kind of the story, maybe to try and queue up for presenting to an audience like APVP, to sort of talk about the application side of things. All right, Greg, it looks like we got everything in chat, Greg.
Yep, I think so. And it usually takes an hour, a couple hours for me to get the Zoom link. What I'll do is when I get it done, I'll send it to everyone.
Yeah, we can work on, and we'll work on trying to get the follow-up email and stuff by the end of the week. It's usually not a hurry. So, Greg, are you in the city? Are you upstate?
Upstate.
I figured you look upstate with the beard and the hair.
Yeah, well, we're about 40 miles from the big Isabella fire, and yesterday it was just dropping ash here. It was like snow flurries on top of the car. It was pretty spooky. It was pretty spooky.
Jill and I are planning on trying to get away for the weekend and maybe go up north, but I'm kind of debating on where to go. So we may stay closer to the south side of the state just with all the fires up there.
Yep, it's probably not a bad idea. So nice seeing you again, Jessica.
Yeah, great to see both of you. It's like a little blast of grad school.
Yeah, it's almost like
it's like a reunion.
Like we would run into each other. Well, yeah, when you're back in town, Greg, because I know last time we screwed up, we weren't able to get together.
I'll be in town next week. I'll give you a call.
Yeah, do that.
Okay.
Good to see you.
All right.
All right, everybody. Thanks. We'll talk to you later.
Bye-bye.